Here we go, 6.3, number 1. So this is 6.3, problem number 1. Excuse my voice, but I'm still alive, so I'm going ahead with this. Now, in this situation, someone has stolen your car. And there's your car, and they're driving away at a speed of 11.2 meters per second. They're going along, and you don't know this is happening. You're just out there hanging out, being happy, when all of a sudden the car hits you. And boom! The car hits you, you're on the hood. You're kind of like, whoa. And it's no good. The car's moving. Now, what we're asking here is how fast the car going with you on the hood after the collision. So we're going to use the laws of conservation of momentum to figure out how fast we're going. So, it stands to reason that your mass, in my case mass Mr. Merritt, actually, let's make it mass person so anybody can know it's mass person, okay? The mass of the person times the velocity of the person initially plus the mass of the car times the velocity of the car initially is going to equal the final velocity of the combined mass. The combined mass have a mass of, well, the mass of the car plus the mass of the person. That's supposed to be a P. Well, plus the mass of the person, okay? So two objects become one object. What's the velocity of that one object? The car with you on it. So I was just standing there minding my own business. Well, anyway, here's my mass. My mass is 108.9. You're probably not that heavy. My velocity was 0. My car's velocity is 10567 kg. And its speed was 11.2 meters per second. Now your car is not going to have the same velocity. We got an announcement here. Your car's not going to have the same velocity.
Please excuse this interruption. Attention all ROP students. Food service occupations after school class at Mountain View High School is canceled for today. Once again, ROP food service occupations at Mountain View High School is canceled today. Thank you and have a great day.
All right, so this is my momentum. This is the car's momentum. Now, why did I choose 11.2 meters per second? Now, 11.2 meters per second should be familiar to you. If you want to deal with it in miles per hour, it's 25 miles an hour. It's the speed that you go in a residential zone. It's the speed you go in a school zone. You couldn't get pulled over driving this fast in a school zone. That's not very fast, but that's the speed we're going to use. Everybody's going 25 miles per hour. So just for this, everybody's going 25 miles per hour. Now, my mass times 0 velocity is 0, okay? Because I have no momentum. I'm just standing still, right? The car is coming in at 17,550 kilogram meters per second. And that equals VF. Now, by the way, the combined masses of the two of us come out at 1676, roughly, kg. So, that's the momentum of the car before the impact. It should be the momentum of us together after the impact. So let's do a little math here, shall we? Now, if I divide both sides by this, the mass of us two together, I divide it by 1676 kg, 1676 kg. That will cancel, the kilograms cancel. And what do we get? 10.5 meters per second is equal to our final velocity. So, now, this should not surprise, well, first off, is this right? Is this right? How do we know if this is correct or not? Well, the car hits me. Do we expect the number to be bigger than it was when it hit me? Well, no, because in theory, I should slow the car down somewhat. So the car should definitely be going slower than 11.2. Am I slower than 11.2? Yeah. Do I expect a lot slower than 11.2? Well, who's bigger, the car or me? I'm pretty big. The car ain't exactly a big car, but even a small car is a lot bigger than I am. So not surprisingly, the car slows down, but it hasn't slowed down that much. So just eyeballing this, if I'd done something